everyone. So in this particular video, we are going to continue our series for PyTorch.nn function, and in this video, we are going to concentrate on MaxPool2d. So MaxPool2d is a very simple function that is used in PyTorch, and in this case, we are going to cover the parameters, which is stride, kernel size, stride, padding, dilation, return indices, and seal mode. Okay, it's a very simple operation. So overview of what is MaxPool2d. So let's say you have a image over here which is 4 cross 4. So let's have 3, 1, 2, 3, and then 1, 2, and 3. Okay, so let's say here are numbers like 2, 4, 3, 1, let's say 0, 1, 6, 5, 2, 3, 7, 7, 1, 1, 8, 0. Okay, so let's say you have a max pool of let's say kernel size equal to 2 cross 2. So what will happen is you will first find the you'll go over here, okay, and then find the maximum number. What is the maximum number? Maximum number is 4, so you'll have a smaller over here and you'll write 4. Then again you will shift it over here, okay, and then what is the maximum? Maximum is 6, so you just write 6. What is the maximum in this one? You say maximum is 3, so you just write 3. What is the maximum in this one? You say maximum is 8, so you just write 8. Okay, so this was the very condensed and the simplest form of max pooling, but we will look into that a little bit. So what is kernel size? Kernel size is basically what I have shown over here. Okay, it is the size of this particular kernel that will be here. Element wise multiplication and weight multiplication isn't there. It's just max pooling, so it will just take the maximum number out of it. Okay, stride is basically generally it is taken as the kernel size only. So let's say stride default value is kernel size. But what if you said stride equal to 1? Then instead of kernel size, why stride equal to kernel size? Because once this is done, it skips this particular thing. Okay, so it's stride here equal to true equal to 2. But what if you say stride equal to 1, then after this particular operation it just goes over here and then again does the max pooling. So here 6 will be taken, and then again it goes over here, again 6 will be taken, so again 6 will come over here. Okay, so this is what the stride is. After that, what you have is padding. Now what padding is there? Padding is basically number of this 0 is not the actual padding. This is basically how much padding is there. Okay, so when you say padding equal to 1, let's say this was 4 cross 4. Okay, so let's say this is 1, 2, 3, and then 1, 2, and 3. When you say padding equal to 1, okay, when you say padding equal to 1, minus infinity will be padded over here in all the 4 directions. So over here also, 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 and so on and so forth, all over here. If you say padding equal to 2, again minus infinity will be padded one more time. So there will be 2 layers of padding over here, minus infinity. So why this is done? Generally to increase the view of the, and we also need to be able to focus on the edge pixels. Okay, so that is why padding is done. Dilation I've already explained in the last video. If you just want to see it one more time, you can go over here, you can click on this, and hopefully it should open. And yeah, so dilated convolution, you can see there are spaces in between. So this is the real kernel, however you can see some spaces are there in between the dark blue and the white light blue. So that is dilated kernel, dilated convolution. And same thing for max pooling as well. Return indices we will see in the code, and seal mode again we'll see it over here in the code itself. Okay, so let's keep it till there. Again here in the same way as convolution, you say kernel size and stride. These can be a single integer. If it is a single integer, then it will be, let's say if let's say kernel size equal to 3, then this basically means 3 cross 3. However, if you say kernel size equal to, let's say 3 cross 5, then obviously it means 3 cross 5. Okay, so if you just put a number, it will then convert it into a tuple of the same numbers repeated. Okay, so I hope that was clear. So let's talk about a simple example where I can explain to you some basic stuff. So let's say you are importing torch.nn as nn, and then you also have a number, you have numbers from 1 to 25 because 26 is not included, and you reshape it in the form 11155. Okay, so that is how you do it. Okay, if you run this particular cell, you will get something output like this. Let me run it one more time, and you get output like 1 2 3 4 up to 25. So this is in increasing order, just so that we can understand. Okay, now what you do is you define nn.functional max pool, which is the same thing as max pool. Okay, this is easier to show, that's why I'm showing it, but it's easier. Okay, so what you do, you pass in the image is over here. Okay, and then you say kernel size equal to 2, kernel size equal to 2, and then you say let me just remove this for now. Okay, let me just comment it for now, just so that I can show you the real basic stuff. Okay, so here what you're having is just image, and then you are saying kernel size equal to 2, and this is 5 cross 5. So what do you think will happen? Obviously, let me just write it over here. 5 cross 5 might not take a lot of should not take a lot of time, but it will definitely clear out the concepts for you. Okay, so here you are going to have 5 cross 5. Okay, so let me just quickly draw 1 2 3 and 4, and here again 1 2 3 and then 4, and you just number these like 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 and 25. Okay, so when you say over here kernel size equal to 2, what it does is it goes to the top and then takes the kernel size equal to 2. Okay, so here what is the maximum? It will say 7. Now it will again go over here, because default is kernel size, default stride is kernel size. So what is the maximum over here? It will say 9, but it will not go over here. Why? Because it will not get the entire kernel. These values are missing. Again it will come down over here, and it will take the maximum from here. It will say 17. Here it will say maximum is 19, and that's it. There is nothing more, because here again it cannot take, and here also it cannot take. So this is the output value. Now let's say you have said that to say your seal mode is actually true. So let's just analyze this. What is seal mode? Okay, so let's go to the code, and maybe I'll do the seal mode later, or yeah, we'll do return indices at last. We'll just say when true seal mode, when will use seal instead of floor to compute the output shape. What does it mean? So we'll best try it only just to see what it does. So you go over here and then you hit. Here you can see the number has increased. Why? Because it has something, you can assume that it has padded it over here. It has padded it over here like minus infinity. Just assume. Okay, this is not exactly what it does, but for our purposes this is enough. So you go over here. Now what will happen is, till here kernel could not come earlier, but now the kernel can come over here. So what is the maximum? Minus 10 is the 10 is the maximum. You got another row. So again here, now the kernel is able to go. What is the maximum? It will say 20 is the maximum, right? So if you go and see over here, there is 3 cross 3 is there, right? So now the kernel can also go over here also. Why? Because the padding is there. So here it will say maximum is 22. Okay, so you can see over here maximum is 22, and again the kernel can go over here, so the maximum is 24, and lastly the maximum is 25. Same thing over here, right? Same thing that we have found. So what it does, it basically adds some padding so that the kernel can go for the maximum stuff also, maximum, so the no particular value from the image is missing. Okay, so that is seal mode. When true, the seal instead of floor is used to compute the output shape. When seal mode equal to sliding window allowed to go off bounds if they start within the left padding of the input. Sliding windows that would start in the right padding are ignored, correct, right? Because it is able to go in the left padding as well. Now we'll finally do our last, which is return indices. So basically what it does is, if you see over here, which index give you the maximum in this particular kernel? This. So the way it is mentioned is, so from left to right it will be numbered. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. But again, this is here value also and the index also, but the value can change. Let's say a 2 by 2 kernel, let's say 3 by 3 only, This can be 8, this can be 2, this can be 6, this can be 4, this can be 3, this can be 1, this can be 0, this can be 9, this can be 7. Okay, so these are already there. And the idea that I am saying is that this particular cell has index of 1, this particular cell has index of 2, this particular cell has index of 3, this particular cell has index of 4, this particular cell has index of 5, this particular cell has index of 6, this one has 7, this one has 8, this one has 9. Coincidentally, what had happened means by design that index value and the value inside the block in this particular image was the same, but in this it was not the same. So in this case, what was the maximum? 7 was the maximum at position what? At position 6. Why? Because it started from 0, 0, 1, 2, 3, 4, 5, 6. So here we will say we will have make another to say here, and we will say 6. So even in the thing you can see over here, if you just say return index, and then you will get that particular thing, but you will also get 6 over here. This is the index one. Okay, this is the 6th, and then 8th one also, again maximum 8th. So in this one, which was the maximum? This particular 9. In this particular block, which one is that? This one. What is the index? 8. Why? This is 5, this is 6, this is 7th index, this is 8th index. So that's why you can see over here 8 is there, and so on and so forth. Okay, so yeah, this is it for this particular video. I don't think I missed anything. And yeah, same this also over here, same logic and same formula as the past, that in the convolution that we have seen. Rest everything I think I've covered. Same logic, the parameters can be either a single integer or a tuple. This has already been covered, and I have also explained if padding is non-zero, then the implicit negative infinity I have already said the padding will be then done, and dilation has already been explained. So I hope you like the video. If you like the video, please like and subscribe. Thank you very much, and bye.